Good morning to all. My name is Suraya Jubin, Assistant Professor in Physics, NTR Government Degree College, Mahbub Nagar. Today we are going to discuss about combination of two mutually perpendicular simple harmonic vibrations, a topic from 4th unit oscillations from first paper physics, mechanics and oscillations for first semester students. So, when we discuss the topic combination of two mutually perpendicular simple harmonic vibrations, then there are two cases in our syllabus. First one, simple harmonic vibrations having equal frequencies, and the second case is simple harmonic vibrations having frequencies in the ratio 2:1. So, these are the two cases which we have to discuss. Today, we will discuss the case having equal frequencies and the simple harmonic vibrations having frequencies in the ratio 2:1. That case we will discuss in our next class. So coming to the today's topic, that is combination of two mutually perpendicular simple harmonic vibrations having equal frequencies. Let us consider two simple harmonic motions. Okay, having same frequencies, or you can say same time period. One acting along x-axis and other acting along y-axis we have to take here. Then the two vibrations can be represented by these two equations. First one, x equal to a sine omega t plus phi, and second one, y equal to b sine omega t. We know that these are simple harmonic vibrations. So the equation of simple harmonic vibration will be represented by these equations. X equal to a sine omega t plus phi. You know that in our previous classes we have discussed about this equation, where x is displacement, a is the amplitude, that is maximum displacement, and this omega is angular frequency, t is time, and this phi is the phase difference, and this total omega t plus phi, this total is the phase. Then here this is along y-axis displacement, so we have taken y. Here the amplitude is b sine omega t. So here a and b are the amplitudes of x and y vibrations respectively. Okay, and phi is the phase difference between the two vibrations, because x motion is ahead of the y motion by an angle phi. This is the difference here, phi. So x vibration is ahead of y vibration by an angle phi. Then this is nothing but the phase difference between the two vibrations. Now what we have to do? We have to take the equation of the resultant vibration. For that we have to eliminate t from equation 1 and 2. For that let us take equation 2 as sine omega t equal to y by b. Already we have y equal to b sine omega t. I am taking sine omega t equal to y by b. Okay. Then what is the formula for cos theta? We know that cos theta equal to under root of 1 minus sine square theta. From that formula I am taking cos omega t equal to under root of 1 minus sine square omega t. Now we have to substitute the value of sine omega t, that is y by b. Then the equation becomes under root of 1 minus y square by b square. Now we got the value of sine omega t and cos omega t. Now this equation 1, that is x equal to a sine omega t plus phi, we have to expand this equation. For expanding, I am taking x by a first here. Then we get sine omega t plus phi. That can be written as sine omega t cos phi plus cos omega t sin phi. Okay. So first equation 1 can be written in this form also by expanding. Okay. Now we have to substitute the values of sine omega t and cos omega t. Sine omega t is y by b, and what is cos omega t? Cos omega t is this one, under root 1 minus y square by b square. Now we have substitute x by a equal to y by b into cos phi as it is, then plus cos omega t under root 1 minus y square by b square sin phi. Okay, then we get this equation, x by a minus I am taking here, then minus y by b cos phi equal to under root 1 minus y square by b square sine phi. So this equation we got. Now we have to square on both sides. So squaring this equation, this above equation, we have to square. So squaring both sides, we have to take square here. Here root will go, we get 1 minus y square by b square, and here sine square phi. Now we have to open this one like a minus b square. So a square plus b square minus 2ab we get. So similarly in the same manner we can write x square by a square plus y square by b square cos square phi minus 2xy by ab cos phi equal to, now I am opening this bracket also, then sin square phi into 1 sin square phi minus y square by b square sin square phi. Now see this equation, we are having x square by a square plus y square by b square cos square phi, and here also y square by b square sin square phi. Now you can bring this here, this side, then we get plus y square by b square sin square phi. I am taking y square by b square common here. Then we get inside the bracket cos square phi plus sin square phi. Okay. Now the leftover will be minus 2xy by ab cos phi equal to same as it is, we have to write sin square phi. But what is cos square phi plus sin square phi? We know that 1. So this we have to take as 1. Then the equation becomes, final equation, x square by a square plus y square by b square into 1 we get here minus 2xy by ab cos phi equal to sin square phi. Same this equation. Instead of this we are substituting 1. Then we are getting this final equation. X square by a square plus y square by b square minus 2xy by ab cos phi equal to sin square phi. Then this equation represents an oblique ellipse. So this equation is for an oblique ellipse. Thus the resultant of two perpendicular simple harmonic vibrations is an ellipse. So we are discussing the case when we are taking the combination of two mutually perpendicular, having 90 degrees angle, mutually perpendicular simple harmonic vibrations having same frequencies. Then the resultant will be a oblique ellipse. Okay. Now here for this final equation we can take many cases. Here what is phi? Phi is the phase difference between the two vibrations. Okay. This phase different value phi, we can take many values for phi. Then we get different equations of resultant vibrations. So we will discuss here 5 cases for 5 different phase values. Okay, like phi equal to 0, phi equal to pi by 4, phi equal to pi by 2, that is 90 degrees, then phi equal to 3 pi by 4, and then phi equal to pi. Okay, so these 5 cases we will discuss. We will put instead of phi these values, and then we get different values for resultant equation and resultant path also. Then we will discuss about each curve separately. Okay, so first we will take the first case, that is phi equal to 0. So let us consider the case when two vibrations are in phase. In phase means we have to take phi equal to 0. Then what is sin phi? Sin phi is 0, and what is cos phi? Cos phi becomes 1, because sin 0 0, cos 0 1. Now substitute this value, sin 0 0, this will become 0, and here we have to put 1. Then the formula will be, the equation 3 will become x square by a square plus y square by b square minus 2xy by ab equal to 0. Then this equation will be in the form of a minus b whole square, like a square plus b square minus 2ab. Okay, like this. So we can write this as x by a minus y by b whole square. Then when we open this, then again we get x square by a square plus y square by b square minus 2xy by ab equal to 0. So I am writing this equation in this form. Then squaring, we have to take root. then plus or minus x by a minus y by b equal to 0, or y equal to plus or minus b by a into x. Now we got this equation. Take this as equation number 4. Y equal to mx, like that. You know that y equal to mx means this is the equation for straight line. So this represents two coincident straight lines passing through the origin and inclined to x-axis at the angle theta. Okay, then what is theta here? Theta is given by the formula tan inverse b by a, because the tan theta equal to b by a. Here you can see b by a. So tan theta equal to b by a. So theta equal to tan inverse b by a. Okay, where a is this distance and b is this distance. This is x-axis, this is y-axis. Then this line represents the two coincident straight lines. This is not one line, but this is coincident two lines which are making an angle theta with the x-axis. Okay, and this is for phi equal to 0. This should be phi. Phi equal to 0, we are getting this type of curve, or you can say line here. So two coincident straight lines passing through the origin, making an angle theta with x-axis. This is the resultant path of the vibrations, resultant vibration. Now we will discuss our next case, in which we have to substitute phi equal to pi by 4. We have taken phi equal to 0 over. Now we will move to the next case, phi equal to pi by 4. Okay, then when phi equal to pi by 4, then sin phi means sin pi by 4, 1 by root 2. Pi by 4 means 45. So sin 1 by root 2, and then for cos phi we get 1 by root 2. Now we have to substitute in this same equation. Instead of cos phi 1 by root 2, instead of sin phi 1 by root 2. 1 by root 2 whole square, we get 1 by 2 here. So answer is x square by a square plus y square by b square minus 2xy by ab into 1 by root 2 equal to 1 by 2. Take this as equation number 5. This is for case 2, when we are putting phi equal to pi by 4. Then the final answer, this equation represents an oblique ellipse. As we have told for equation 3 also, this type of equation always represent an oblique ellipse. You can see in the figure also, this is ellipse but not direct ellipse. It is a inclined ellipse, or you can say oblique ellipse, when phi equal to pi by 4. This is the second case. Now we will take the third case. What is third case? We have to take 90 degrees. First we have taken 0, then 45 degrees, pi by 4, then pi by 2. That is 90 degrees we have to take. So this is when phi equal to pi by 2. Then sin phi, sin 90 equal to 1, cos phi equal to 0. Cos 90 means 0. We have to substitute these equations in equation here. Then cos phi 0, so this total becomes 0. We get x square by a square plus y square by b square equal to this 1 directly. So the final answer will be this one, x square by a square plus y square by b square equal to 1. Take this as equation number 6. Then the resultant path is an ellipse, direct ellipse, not an oblique ellipse. It is an ellipse whose major axis coincide with the coordinate axis as shown in the figure. So this is the major axis of ellipse and this is the minor axis. So this is the ellipse whose major axis coincide with the x-axis here and minor axis with y-axis here. So the resultant path in the ellipse. This is for case 3, when phi equal to pi by 2. We are getting an ellipse. The resultant path of the two simple harmonic vibrations having perpendicular simple harmonic vibrations having frequencies in the equal frequencies, and the path difference between the two vibrations is 90 degrees, pi by 2. Then we get the resultant as an ellipse. Here in this case, case 3, when phi equal to pi by 2, we can take another subcase also. What is the subcase? When phi equal to pi by 2 and A equal to B. What is AB here? We know that AB are the amplitudes of X and Y vibrations. When these are equal, the amplitudes are equal, and phi is pi by 2. Okay. Then X equal to A sin omega t plus pi by 2, like that, and Y equal to A sin omega t. Same A we have to take. Then the final answer will be here. X square by A square plus Y square by A square equal to 1 we get. A square we can take common. Then the final answer will be X square plus Y square equal to A square. Okay. So the final equation will be X square plus Y square equal to A square. This is the equation. You know that this is equation for a circle. Okay. You have an idea that this is an equation of circle where the radius of the circle is A. So X square plus Y square equal to A square. This can be represented by this figure D here. So this is the radius of the circle. Same we got here an ellipse having a semi-major axis and semi-minor axis AB. Here A and B are equal, so it will now transform to a circle. Same figure is converted into a circle when A equal to B. So this is also the third case only, when phi equal to pi by 2, when the simple harmonic vibrations have a path difference of pi by 2. Okay. Now we will move to the next case, that is phi equal to 3 pi by 4. Okay. Then when we take phi equal to 3 pi by 4, that is 135 degrees angle, then sin phi equal to 1 by root 2 and cos phi equal to minus 1 by root 2. You know these values. So same as you got in case 2. I will show you what is various. Okay, here 1 by root 2 and 1 by root 2, and same this formula we got. Here also we get same formula, but instead of here 1 by root 2 we get minus we get plus here, like this, minus 2x by y by ab into minus 1 by root 2 equal to 1 by 2, or minus into minus you can write plus 2xy by ab into root 2, or same equation, but the sign will be changed here. Instead of minus we will get plus. Then this equation represents an oblique ellipse. Same equation, so we get same ellipse, but here the oblique is different. Here we get an oblique ellipse like this. It is inclined towards this side. Now you got the inclination is this side. This is the change. Same equation, same figure, oblique ellipse we get, but here first we got like this inclination. Now we are getting like this. The sign is changed here, so the inclination is also changed, where phi equal to 3 pi by 4 for this. Now we will take the last case, that is case 5. So what is case 5? When phi equal to pi, that is 180 degrees. Then sin phi equal to 0. We know that sin 180 degrees also 0, and for cos 180 degrees we get minus 1. So x square by a square plus y square by b square plus 2xy by ab into minus 1. So minus into minus we get plus here equal to 0. As you got in equation 1, first case here, like this. Same, but here we got minus. Now we get plus here. Okay. Same, but plus sign here. Then we can write x by a plus y by b whole square equal to 0. In the previous first case we get here minus. Instead of that we get plus here. Then x by a plus y by b equal to 0, or y equal to minus or plus b by a into x. Okay. Same equation, straight line equation. Again represent a pair of coincident straight lines passing through the origin and inclined to x-axis at an angle theta, given by theta equal to tan inverse minus b by a. Okay. Here you will get same equation. So same straight line. First case we get like this. The straight line is like this, making angle theta with the x-axis. Here it is making an angle theta with the minus x-axis. Okay, that is the difference here. When phi equal to pi, we are getting resultant path of the two simple harmonic vibrations, mutually perpendicular simple harmonic vibrations having same frequencies, and the phase difference between the two vibrations is pi 180 degrees. Then we get a path, resultant path as two coincident straight lines. So now we have discussed all the 5 cases. So these 5 cases can be represented by this. Hence, in the combination of two mutually perpendicular simple harmonic motions of same frequency, the resultant path of the particle can be represented by the following curves. I will show you all the curves here. This is first one, 0 we got. Okay, this is the first figure we got for phi equal to 0. Second, phi equal to pi by 4. This is the oblique ellipse towards this side, oblique. Next, pi by 2. Okay, this is ellipse. Okay, in this case only we got circle also. When a equal to b, we get circle. Okay, you can imagine. Then 3 pi by 4. For 3 pi by 4, we get oblique ellipse only, but the inclination is towards another side. Then again straight line in opposite, making an angle theta with minus here like this. Then these are the extra cases we have not discussed, but when we take the total, then we get this like this. For 5 pi by 4 we get like this. Then 3 pi by 2 we get same image, and for 7 pi by 4 this same like this. The 3 are same as we got here. So total we are taking 8 cases. In our syllabus we are having 5 because all the next remaining extra cases, they are similar to these 3 cases. So in combination we can take 8 cases, and these total 8 cases can be represented by a simple GIF here, graphics interchange format. In this you can easily understand what is the meaning of the curves. As you can see, this is the combination of two straight lines, you can see. Okay, this. Okay, then it is converting to ellipse, oblique ellipse. From two lines it is converting to oblique ellipse, then it is converting to a ellipse, then circle, and then again it is moving its direction, reversing its direction like this. So in this curve you can see all the combination of 8 curves, two straight lines, ellipse, oblique ellipse, ellipse, and circle also. So these are called as Lissajous figures. A name given to these type of curves is Lissajous figures. We will discuss about these Lissajous figures in our next class, after discussing another case related to combination of two mutually perpendicular simple harmonic oscillations having frequencies in the ratio 2:1. In that case also we will get some curves. Then after that we will discuss about what are Lissajous figures and what are the uses of Lissajous figures. Okay, thank you.